Okay, let's begin.
All right. Okay, so Defn, episode 2. Welcome.
Hello, this is Vijay.
Hi, this is Ray.
So apparently we forgot to, at least Ray forgot to mention his name, so I think you should introduce yourself, Ray, again.
Okay, yes. That was a bit, I was too excited last time. Keep on saying last week, I don't know what it is. Anyway, I'll get my name out now. Ray McDermott, here in Belgium, Vijay Karan over there in Holland, Defn episode 2. So it's been an interesting 2 weeks, hasn't it, Vijay?
Yeah, I think it's been very exciting. I mean, I never expected this amount of reaction from the listeners. I mean, it's amazing.
It is phenomenal. Yeah, I can't believe how much attention the podcast has got, to be honest.
Yeah, I think we had more than 1,000 listeners on SoundCloud or something.
Yeah, it was well over 1,000.
Yeah.
Which is incredible, and lots of positive feedback on Reddit and Twitter, and really, really good. I mean, it shows there's a hunger for information out there in the Clojure world, and if we can feed it a little bit, then that's great.
Yeah, that's the whole goal of our show anyway. So I've been very humbled by a lot of nice feedback we've been getting. And of course, there was a little bit of a technical hiccup in the last recording, but I think we have fixed it now. So this the sound quality should be much better from this episode.
Yes. Okay.
Okay.
So, fantastic. Yeah. Big week this week, eh?
Yeah, I think the amazing spec has been released, which is fantastic news for Clojure, and because I think most of the guys have been settled on schema one way or the other, but it is very nice to see Richiki taking more hammock time to think about this stuff and then come back with spec into the core. So that's pretty amazing.
Yeah, I agree. I mean, what's by the way, just as out of interest, news never happens in Clojure. We get announcements so rarely.
That's true.
It just happens that after the first episode, he chooses to release spec. So, good timing, Rich.
Of course, yeah. I'm pretty sure he's listening to this and laughing out loud all the time. So, I hope. Rich, if you're listening to this, I'd be happy to have you on the show and tell us that we are. Yeah.
My headphones just fell off at that point.
Okay, I apologize for starting with big jokes. But yeah, I mean, spec has been pretty decent. I mean, this is one of the nicest things, at least if you see schema, but taking that into next level, which is awesome. I think we should do a complete episode on spec and
I think you're right. We'll let the dust settle a little bit on it, because I noticed, by the way, that Rich actually is still in the Slack channels and this kind of stuff, and on the emailing lists, slapping people about using it for parsing text and shit like this. Yeah. So yeah, the dust is still settling, that's for sure. But let's just have a quick. I mean, what you mentioned there about the prismatic stuff, because that has been an absolute, a phenomenal thing. We've had a lot of this stuff from Ambrose stuff, the gradual typing stuff, the core typed, and I think that's been an interesting experiment. But the thing which is like really practical, the thing which really the community's got behind is the prismatic. I think it's now plumatic, actually. I forgot
I think it's plumatic. Yeah, true.
And I think that's actually, we've got a lot of mileage out of that. So I think kudos to those guys. And I don't think people will drop it straight away.
No, not necessarily.
People will still be interested in it. It's still got a lot of mileage in it. Yeah, it's still got a lot of value.
Yeah,
but he did do some interesting things this time with spec. He made some interesting reflections, didn't he? Against prismatic, where I think one of the biggest differences is you don't have to provide the typings for the keys.
Yeah, that's true. So there is much more decoupling in terms of what you can specify. And also, I mean, the other nicest thing that I saw is that you get this generative testing for free. That was most exciting part for me.
Absolutely so incredible. Maybe we should just quickly say what spec is, though, just because I didn't think we did that yet.
Oh yeah, I think it's better to give a quick overview of spec. So spec is essentially something like what we call occurrence typing. So this is because Clojure has been always what you call like a optional typing friendly, optional typing friendly language, because everybody wants to get into adding types later than specifying types up front. And if you see, and also it was very difficult to provide or validate the data schema, so to speak, and that's the reason why the name of the library was also schema. And of course you can write documentation and you can specify what it means, but it's not good enough. So spec is essentially going to give you a couple of things like how to validate the data and destructuring, and you can instrument the stuff that you have, and you can have generative tests, I think automatically generating generative tests, and also error reporting. So you should have all these features using a library like spec.
I think that was one of the things to me when we looked at things like core typed and prismatic schema, and the generative testing tools. They looked so close to each other. This is one of those frustrating things, actually, was that they were always kind of they didn't play well in an ecosystem with each other. They were kind of stepping on each other's toes. Yeah. That's the nice thing about this stuff, is that it does harmonize a lot of those thoughts. And it makes it practical as well. So I think that's going to be a huge win, I think, for the community.
Of course, and also moving it to one of the core libraries makes it available to everybody. So that is much more. Maybe I don't want to call it a blessed library, but at least there is a standard now. Everybody can use in the community, and that everybody can reap benefits out of it. So that's pretty awesome.
But I think it is a blessed library, isn't it? I don't think I think anything that comes out of Cognitect tends to be
that's true.
Tends to be blessed. I mean, I think there's a few things that are a bit, let's say, unblessed, like Pedestal, perhaps. That's kind of like it's no one's hating on it, but it's not a core thing. Where this really is.
That's true. Yeah,
core
this is part of
like core async and that kind of stuff, isn't it? This is definitely there as something which Rich and his core team are kind of standing behind.
Yeah, but anyway, I think we should move on to the main discussion for this episode. We should certainly do an episode about spec. I mean, we'll discuss more about spec in the future episode.
I think also please try and schedule your announcements around our show timing. That would be good.
Yeah, I think that's our humble request to the Clojure community.
Yes,
so we'd have a lot of stuff to talk about, obviously.
Yeah,
and we'd like to take the false credit of, hey, we poked them to do this thing, or something like that.
Yeah.
But anyway, so to the main discussion for tonight. So we promised the internet that we are going to do an episode about Reader this time. So
I think what maybe just to back up a little bit on what you were saying there is that I think a lot of the feedback that we got from the first episode was, yes, okay, it's good stuff, it's nice start, and obviously I think people will try again, hopefully, and give us a second chance, stay with us. This is definitely going to be a more technical episode. We're going to be going into stuff which is a bit deeper. I think let's try and get a balance between. We're obviously always trying to get a balance between stuff which is good for people that know Clojure and people that don't know Clojure at all. So So we'll see how we get on, because we've got a list of things to go through on this reader, and it's some of it's a bit arcane, a bit technical. So hopefully we can keep it accessible. But anyway, let's like you say, let's crack on.
Yeah. So what is the reader? So why reader is so important in Clojure and Lisp? Well, maybe we should start with that part.
Yeah.
So in my mind, so if you see the compilation phases for any given programming language, you have multiple steps, multiple phases in the compilation. You have the first step as lexical analysis, or there is a lexer that is going to. So you're writing code, and code is essentially stream of characters. You're typing in with your keyboard frantically, and then you save it to a file. That is basically.
Do you have to do it frantically?
I think so.
Okay, just checking.
Because that's the nice part, right? You spend enough time in the hammock, and then the only delay is your typing speed now. So you have to type very quickly to move your thoughts onto the files.
Right. So I just went off the topic completely there. Sorry. Yes. Back to the frantic typing. Okay. Yeah.
Yeah. So you have these characters, and those are in your files, and your program is there, and then you use lexer, and then lexer is the one in the compiler phases or compilation phases that produces what we call tokens. And then you have a parser that is going to do some sort of a syntax tree or a parse tree that is going to generate a proper syntax out of it. And I think that's called parse tree or something. And then you have the semantic analysis, which is the analysis phase, and you get the AST. And from the AST, the final step is usually either generating the machine code, or in the case of JVM languages, maybe a bytecode, or in the case of JavaScript, it's JavaScript.
Yeah.
So you have these different phases in the compilation, and an interesting factoid is that the latest Scala compiler has 25 phases. That's that's fun.
25 phases.
Yeah, I mean, I don't want to poke fun at Scala guys, but I mean, it's a fairly complex language, so you need all these phases to generate these things. But coming back to
but actually, to your point there, that the Scala guys have added like some kind of macro. It's a fairly naive macro implementation to their language. So I guess that adds a lot. And obviously they've got all the functional stuff, the OR stuff. It's a pretty complicated language. Yeah,
that's true. Yeah. So it's a complex language.
Ambitious project, that's for sure. Yeah.
Exactly. So it's a complex beast. So obviously their compiler is much more. It's not that easy. And coming back to Clojure and Lisp, I mean, essentially reader, you can treat reader as a combination of lexer and parser, because those two steps are essentially the same in Clojure. So and that is, I think, as you were pointing out when we were discussing before the show, it's essentially literally the UI of the language. So that's where the first part of the compilation step. So it also validates.
Sorry, go on.
Yeah. Sorry. Go ahead.
I was going to say, the other interesting thing about the reader is that it does have uses on its own, and we'll see a bit later in our conversation, won't we, about like the Eden and stuff like this, which, so, I mean, I know that some people use preprocessors or JSPs or these other type things as kind of like tools on their own, but they're also less powerful, I think, typically than these readers are. So I think what's nice about it, I guess, is at the very beginning of the language, even in the actual tools to understand the language, you have decoupling between read and eval and print and then loop. So the reader is in itself a tool that has some usage outside of just purely the REPL.
Yeah, that's true. So because the reader is one of the, I think we'll probably discuss a bit what reader provides in terms of those things. So sure. So that gives us much understanding. I think you were pointing out that reader is more like you can maybe compare it to the C preprocessor, for example, especially when you have the branching in the code. So with the CLJC things, do you want to explain the comparison a bit?
Well, my thinking was actually to compare it negatively.
Yeah, of course. I mean,
well, mostly the interesting thing about let's say the reader is that it's not dumb, whereas the C preprocessor is a pretty dumb. Just a kind of thing that runs over your file and just cuts and pastes symbols. So you hash define X to be ABC123, and then whenever it finds hash X in any of your C files, it just replaces it with ABC123. And just cutting and pasting en masse is not the same kind of macros that Lisps have.
Yeah, of course. I mean, I think as you're pointing out, it's essentially operating at the lexical level. I mean, it's just moving some text from here to there. Yeah, and that's what it is essentially doing.
Yeah, it doesn't actually. The other interesting thing is that the C preprocessor doesn't understand C at all. It doesn't need to understand C. Has no bearing to C at all. It's its own little mini language. Whereas the reader is a complement is part of Lisp, and it's a complement to the language as well.
Yeah.
So I mean, obviously, the kind of if-def things where you want to hide or show certain bits of code, there is a little bit of that with this cross-language stuff between reader conditionals, between Clojure and ClojureScript, and we'll come on to a bit more detail about that later. Yeah.
So the nicest part is that at every point you're producing in all these compilation phases, where you have reader, you have analysis, you have macro expansion. At every point, all you're getting is Clojure data structures. So so you can operate on them. That's the whole definition of having access to Clojure forms everywhere with the Clojure library. So you can use the language to manipulate how the language is getting compiled. So that's the home iconicity that we have. So which is pretty interesting in terms of how readers operate. And I think if we see what reader is doing, so there are some fundamental forms that reader can understand. There are symbols, literals. So if you type a form is essentially an S expression. So anything that begins with a parenthesis, for example, and the reader understands it and then converts them into Lisp AST or quote-unquote AST, which is essentially Lisp again.
Mm-hmm.
And we have different kinds of reader forms. I'm not sure if we can go through all the reader macro characters, though, but maybe we should explain a bit what they do. So there are some specific characters in the language that are picked up by the reader and interpreted differently at the reading phase. So I think it would be horrible if I keep pronouncing these symbols, though.
Yeah, but I think there are some funky things, aren't there? Like when you first start doing it in the REPL, if you just type, I think if you just type "Hello World," for example, as a string, then you'll get back "Hello World" as a string in the REPL, and that's just because it recognizes that as a literal,
Exactly.
And if you type in, I don't know, something like plus, and then you have 1, 2, 3. Well, it recognizes that as an S expression. That's all good. And then you can, like you say, you can do quotes, and you put a quote in front of a list. And then that list is no longer evaluated as a list, but it's actually taken as
literal
value.
Exactly.
So there's some nice, interesting things there in these macro characters.
Mm. Yeah, so
sorry, go on. I interrupted you again.
Yeah, so one of the interesting, at least a couple of things that stand out for me is the metadata thing. So you can attach additional metadata to a given symbol or given, I think essentially a symbol. You can attach metadata. You can specify.
You get some typing hints there, don't you? Actually, because that's true. That's the other thing. And actually, bizarrely, I was looking through some code today, and I'm ashamed to admit that I only discovered today how you make a def private, and that's through this metadata.
Yeah, that's true. Yeah,
which is I'm sorry, everybody.
We're still learning, so that's fair enough. But I think one time I used the metadata or the type hints, or I was writing a small numerical library, and instead of using just to prevent reflection, essentially, I specified Java long or whatever for the numbers, and that was much more useful because and also making some constants, those kind of things. It's very useful. And the other stuff that stands out is the syntax quote and the unquote and unquote splicing that enable you to write a lot of macros and in a cleaner way. So you start with the literal, but in the body you want to eval it again, and then in the body you want to go back to the literals again. So you can do all this macrology with these reader macro characters.
Yeah, I think we'll probably in the course of this podcast life, we'll definitely have to talk a lot more details about macros one of these days, because sure. I know that it's one of these things which is let's say underplayed in Clojure, or downplayed, let's say, rather than underplayed, because obviously there's a shitload of macros in Clojure. But it's downplayed because people would have data first, then functions, then macros. But I think it's important enough for us eventually to have a longer conversation about them.
Yeah, certainly. Yeah.
I was just going to say, one of the things about all these like ints and longs and stuff like that, though, I don't know about you, but I find it a little bit ugly. I find it a little bit kind of anti-Clojure. It starts to look a bit yucky. I know you get better performance out of it and all that kind of stuff, so I see why people do it, of course, and you have to do it. But it does start to feel like, well, what the hell, we came here to get away from these types, not exactly, but but at least you have to put these frigging types everywhere, then it looks horrible.
Exactly.
Which is why I like spec, actually, because in the end you can do both, of course.
Yeah. I think one of the major use cases for specifying the types is to prevent reflection. I think that's what I would think, because even I know every time people talk about Clojure, then it's essentially becomes a war between static typing or optional typing. So that's something that I don't want to get into. But sometimes you want to have.
We're in there, mate. We're in there. We're in that war.
Maybe
we've taken a side. It's okay. Yeah,
exactly.
I mean, obviously, with the spec thing, that we're offering a little token towards the typing people.
That's true.
But we can take that when we want it. That's really good. But we've taken a side. Come on.
Sure. I mean, I picked the right tool for the right stuff. So I don't want to be too diplomatic, but I prefer Clojure because it doesn't force me to do things like specifying the types all the time, and that's not something. Most of the problems that I'm working on are essentially data manipulation. So I don't want to spend additional brain cycles on first thinking about the types and then dealing with the data, because in the end I'm throwing the stuff into JSON, and what types do you have there? Essentially none. So
we'll come on to that in a minute, actually, because we're just since we're talking about JSON, we should maybe talk about Eden.
Yeah, that's true. So
because that's also a part of this reader thing,
Yeah. So I think we should explain what Eden is. So Eden is essentially EDN, extensible data notation. So that is one of the underlying.
I think the background of that is that. I think the background of that, isn't it, is that I think it was the criticism of JSON basically is that it's not extensible. That's really the kind of motivating force, if you like, or motivating idea behind Eden and Transit and all the kind of Clojure data formats is we have to keep the data format extensible. We don't want the horror of XML back, but we want the advantage of XML, which is the extensibility.
But there is an interesting thought experiment. I don't want to call it a thought experiment, but some people claim that XML is essentially Lisp in angular brackets. So, or maybe I should say XSLT, not XML, but XSLT. It has the similar notions, but I think it's too spiky with the the angle brackets. I think parentheses are much more smoother to look at. I don't know. It's my personal preference.
Yeah, you don't have to say open brackets plus and then have a close bracket /+ at the end.
That's horrible. Yes,
mental.
Yeah. But maybe I think I have some more things to say when we want to say something about the reader macros, though. But I'll hold the thought for until we get there. But we should get into Eden a bit.
All right. Okay.
So
Eden, So the main thing is it's extensible. That's the main point, isn't it?
Exactly. And also it's the essence of Clojure syntax. I mean, it's the basis of Clojure. So we keep saying, hey, code is data is code is data is code, and recursively so on and so on. So Eden is essentially the fundamental syntax of Clojure. So you have all the list and maps and whatever that you're used to in storing the data in Clojure. All those literal formats are in Eden. So I remember that there was this training by Stuart Holloway and Neil Ford, I think.
Oh yeah, I've seen that. Yeah, on the O'Reilly stuff. Yeah,
exactly. I think that they start the course with Eden. Not with Clojure, but with Eden. So they first explain what Eden is, because that is what Clojure is essentially in terms of how it looks like. and then they moved to Clojure.
I'd forgotten that actually. Yeah, but you're right. Yeah.
That was a long time ago.
Yeah.
Yeah. We had I'm not sure if I can say this online, but what the hell? Because
as long as it's not one of these kind of Gorka things where we're gonna get sued out of existence.
I hope O'Reilly guys are not gonna get pissed off with me. But we had a viewing party of this episodes actually. I mean, we spent like whole day, and there were around 10 guys and 10 folks sitting together and then watching the whole Clojure thing. The whole training by Stuart Holloway and Neil Ford in. I don't want to specify the place, just to be sure.
No, exactly, yeah. But that's a hell of a party, though. Yeah. Okay, anyway, right, back to Eden.
Yeah.
Yeah, so yeah, you're right. Anyway, so it's all the kind of the formats that you like you say, the lists and all that kind of stuff.
Yeah, but it didn't pick up, right? I mean, Eden was too Clojure specific, and it of course you can have Eden as an interchange format between different languages. That means you had to have Eden parsers in the other languages.
Yes.
So that was one of the painful things with Eden. It's a perfectly suitable format if you have front end in ClojureScript and back end in Clojure, obviously. Then it's easy to just shuffle Eden around. But that wasn't the nicest format to be used.
Yeah, I think part of the sort of hampering of the adoption was that people were saying, okay, well, I like the fact that you've got this extensible data notation, that's all good, but I'll tell you what, if I just put it out into JSON and I read it into my front end browser, it goes about 1 million times faster than Eden does.
Yeah.
And that hurt, I think.
Yeah, that's true. And then we have Transit.
Yeah.
Which is essentially kind of a better format and better transitory properties. Is that a word? I don't know.
I don't know it, but
okay, maybe I should explain what it means in my brain. So you can interoperate with other languages easily. So you can send the format because it can be passed by JSON easily, JSON engines or JavaScript engines. And it's much more compact. I think it is binary, so it's much easier to send over the wire and parse it and use it.
Yeah.
But still, I think there are some projects I know that were using Transit on GitHub, but I didn't see enough things that are getting picked up by the community a lot.
Again, I think it's one of these things which is not seeing a huge adoption out in the wild. But but obviously, I think if you look at the kind of Omnex stuff, then I think they're using it as a means to transfer data backwards and forwards. Yeah. Also, if I remember rightly, the thing about Transit is that you can, if it's seen a particular value or a particular key, then it can cache it. So you can speed up quite a lot that way, which actually makes it faster than some JSON engines as well.
True. So I think we should connect it back why we are talking about Eden, because Eden is the stuff that is read by Clojure Reader. So that's the idea behind having Eden or talking about Eden. And
that's why I was saying at the beginning that it's one of these things where Eden shows that the reader has got more value than just in the REPL.
Yeah. And obviously Eden, the whole extensibility is coming from the tag literals. Tag literals are essentially the things that in syntax wise it is basically hash and a word, and there are some default or a built-in tag literals that you can use. So if you put a literal string for date, for example, then you can use instance tag literal, and that will be read as Java util date, I think, at least in Clojure. And in CLJS probably it will become JavaScript date, I think. And you can also have your own custom tag literals, they're called data readers.
Yes.
What's the thing called again? I think it's called earmuffs.
The star, blah, star.
Yeah, star, yeah. So you can have your own data readers, and that is the extensibility comes in. That is where extensibility comes in. So you can define your own namespaced tag literals. For example, if I have a map with a person and I can put a tag in front of it and call it, my namespace /person, and then put a literal representation of the map, and my reader or the data reader for that map will become will convert that into a person object or person struct or record, for example.
Yeah, I think these are quite powerful things actually, because that's, for certain. I mean, I don't know. I mean, I like UID and UUID and time and stuff like that. I'm a bit negative on the whole kind of person stuff, but I like URLs and kind of like things which are fairly generic. In the actually, I don't know. I know I saw a video of Steve Miner from a few years ago on Clojure West talking about his tagged library, which allows to do printing of def records, which is interesting. So you can do that at the REPL. But the other thing that I don't know actually, maybe we should have talked about this before actually, but I don't know if there's a kind of library out in the wild there of these generic things like hash URL or hash, like hash. I'm struggling now. I have to cut this. I'm wondering
because in general,
hash thing.
Hash thingies.
Well, we can definitely have a hash thing. No, but I'm trying to think of some generic types of things like obviously UUID and time is one. URL is another I can think of immediately. IP address, let's say.
Exactly.
There are certain or telephone numbers or emails. I'm on my floor now. I can do it now. So things like that, like hash email would be a good one. Yeah, but you can have or hash postcode or something like that.
You can have domain-specific things like the bank account numbers, IBAN numbers or something.
Right. But those, my question is, do we have those? I mean, I don't know. Maybe it's actually this could be a call out for the listeners actually.
Yeah.
If they know of such libraries, because maybe it's just another form of lazy web here.
Yeah, exactly.
Because I'd quite like to know about them.
Yeah, and also how pervasive is creating your own tag literals, because one of the suggestions was that every time you use a tag literal, don't pollute the top level namespace, but introduce tag literals for your own namespace. So these things look a bit like reader macros though, right? I mean, or at least
definitely
compensating
a very limited form, obviously, very limited form.
Exactly. But we'll get into reader macros later. But the tag literals are interesting, and I think that is one of those things that give Eden the whole extensibility, I think.
Yeah.
So anonymous functions, for example, and the metadata probably, as we talked about, and the deref thing whenever they want to deref an atoms. Yeah. And whenever you're commenting, you're essentially talking to reader in a sense. You're skipping away things. And I think we should talk a bit about the security related issues with reading stuff. Because reader is the one that provides the read function, right?
Of course, yes, that's right. Yeah.
So,
but actually, I guess there's two parts to reading, isn't it? I mean, obviously, if you're going to read your code, then that in the end causes eval, doesn't it? So you have to make sure that you're reading from a trusted source. Yeah. But there is a version of read from Eden where you're not allowed to do these evals. So that's that was a worry when I think it was in 1.5 when it first started, where there was a security risk at the beginning.
That's true. Yeah.
But that's closed down now. Thankfully.
But now everybody should use the Eden reader instead of the core reader, I think.
Yes,
it's not discouraged a lot.
Yeah.
But there is is this the same? You said there was a talk about Steve Milner. That was
the tagged library thing. Yeah.
Okay. Yeah.
That was in the Clojure.
Clojure West
from a few years ago. Yeah.
Maybe
I did see another one by this guy called David Greenberg, which was definitely a very wacky kind of way of using. Or it was, to my view, it was a bit wacky view of using tag literals, which was this Spyscope. So you could, I think it was hash. It was hash spy and then /trace or hash spy and tag and stuff like this. And the idea was that in your REPL you could essentially put a little watch on variables or forms inside of your code. so you could embed these tagged literals inside of your code, and of course they would get expanded by his functions. So they could be printed out and all these kind of things. So it was a kind of limited form of debugging.
Yeah, that's true. I think it's I don't want to call it. Well, this is a interesting or quote unquote interesting use of tag literals, I think, because when you pointed out, I was looking at the code and so it's essentially providing a couple of data readers. So data readers are something that you that is essentially a small map that says, okay, if I see this tag literal, then this is the function that should be called.
Yes.
So it's basically a mapping between these things. So if you say hash person, and then there is or maybe I should say hash namespace person or something, then you should invoke a person constructing function, for example. So the Spyscope, it looks very interesting to me, at least for debugging, what is happening in the system. So maybe this is not the original intention of the tag literals, but still, I mean, it's an innovative use, certainly.
Yeah, I mean that's definitely very close to a reader macro. I think that usage.
Yeah.
Maybe the author would disagree there, but that's the way I look at it anyway.
Yeah.
Okay, so
if David Greenberg, you're listening to it, please find Ray on in Twitter and then just shout at him.
I'm sorry, David.
Tell him you're wrong.
I've misunderstood. To be honest, I mean, I typically, I don't always use a fancy REPL from Cursive, and I think if I was using a more primitive REPL and that's all I had available, then this Spyscope would actually come in a bit handy. But I think these days, because I use Cursive all the time, it's got awesome debugging, and I think it probably supersedes most of the stuff that's in there. But like you say, at the end of the day, it's kind of like a proof of concept, if nothing else. It's an interesting way of using these tagged literals.
That's true. But I should probably clarify to the listeners that when you are saying primitive, you mean the most advanced REPLs like Insider in Emacs, right?
Yeah.
I think we're gonna have a fight on podcast soon, like Cursive versus Cider.
All right, okay. I'm looking forward to it. Bring it on.
So Cider is
I'm not sure it's
alcoholic
the medium to do it, but what the hell?
So Cursive has curse in it, and Cider has cider. So pick your battles, man.
Actually, I think you win on that basis alone.
Okay, no offense to Cursive people. So I apologize. But I think the next interesting part in Reader is that the Reader conditionals. So we were explaining a bit about the if-def sort of stuff in Clojure.
Right.
C preprocessor.
Yeah.
So you can have essentially conditionally compile the stuff. I don't know if have you ever seen the .h files or the header files in cross-platform C programs. They're horrible.
Oh God, yeah. Oh yeah. I worked with C professionally for nearly 10 years, so I'm burnt by that big time. Yeah. Oh God.
Okay. But there are interesting stuff in.
Oh, sorry, go on. Yeah, I don't want to go into my whole history of the horrors of C programming and stuff like that. Yeah, okay. But yeah, horrible times.
Maybe that should be another episode that says how I moved from C to Clojure.
Oh God, yeah.
Both starting with
there
C.
are many other languages in between, but yeah.
Of course.
But that's
But they're still around, right? I mean, if you're writing iOS code, for example, you would check for the screen size and all the crap and what kind of platform you're on, and yeah. Anyway, let's not.
Well, I don't think you need to do that anymore. In all fairness, I think most of these things are fixed. But most of the things that I remember from the C days are actually a bit like this in the sense that if I'm not rude about it, really, is that people tended to use C macros and hash defines to do platform specific things. So you'd have particular things for x86 or for Spark or for RISC or whatever chipsets you wanted to do. Obviously, it's a lower level than Clojure and ClojureScript, but it's a very similar concept.
That's true.
You wanted to branch for this particular type of hardware and run this particular bit of code. Or you'd want to branch for another bit, but I think it's only like that from a distance, really, with a squint. I think.
Yeah.
But I think it has some equal issues in the sense that it can become a bit difficult to read. And I think if you overuse this kind of stuff, then you will land yourself in difficulties.
Yeah, that's true. But it also enables one of the nicest features, right? I mean, you can have the same code, which is, or at least non-platform specific code, written in a CLJC file, the conditional clojure file, and you can use the same code in the front end if you're using a clojure script, and you can use the same thing in the back end. So this is like one of the nicest features of having a reader conditionals, and also the whole CLJC files.
I totally agree. Yeah, I mean, and let's be honest. I mean, I'm kind of I don't be too negative about the confusion, because most of our functions that we really write are kind of less than 10 lines. So it's very different from the C preprocessors where you'd go like, if Spark, 100,000 lines of code, else. Yeah. You couldn't hold that in your head. Whereas, so this is very different. I agree. And this actually, we've got homoiconicity, at the beginning with the reader, and now we've got isomorphism. So if you're not bewildered already, you are by the end of it. But exactly. But this isomorphism, this ability to run it, on the back end and the front end, that's something which the JavaScript guys are also talking about with Node and the browsers.
So you take the same code that is running in the browser and then move it into Node.js or something.
Yeah.
But the nicest part for me is that one of the simplistic examples is that writing some domain validation code, and you can just put it into a CLJC file, and you can ship it to the front end where you can use the same validation functions, and you can use it in the back end. And so that is one of the simplest use cases I have in my mind for having the same code across different places.
Definitely, that's a huge reuse win. That is,
yeah. And I think one of the I'm not sure how many people actually dig into the source code of Clojure compiler though, because
probably not that many.
Yeah. But it could be.
But go on. Yeah.
Yeah, it could be a fun exercise. But what I was alluding to is that we have this Clojure. Essentially, all the reading is happening in Lisp reader.java in Clojure compiler. Not too long, fairly standard parsing and lexing and parsing code. But one thing that is much more interesting for me is the clojure.tools.reader, which is actually reader written in Clojure.
And that's really awesome. Yeah,
exactly. That's really super fun, because that is one of the things used in Clojure script compiler. So they're in compiling Clojure script, which would mean essentially compiling and parsing Clojure. Okay, I think I need to explain it a bit more. So you're writing Clojure, and Clojure script is essentially similar language. I mean, for all intents and purposes, except that there are some exactly. So you would want to use the same code that you're going to parse Clojure and Clojure script, because they're the same languages. But you don't want to use the whole JVM driven parser. But if you see Clojure tools reader, which is actually Clojure parser or Clojure reader written in Clojure, and that's what being used in Clojure script, which is one of the nicest things, because I think I may be wrong here, but this is one of the steps where you can go into Clojure in Clojure, for example. So bootstrapping Clojure and then essentially writing Clojure in Clojure. I know it has never been one of the goals of the community, though.
Well, yeah. I mean, I think like we were talking about this a while ago, is that essentially this proves the point, doesn't it?
Yeah.
If you can write Clojure script in Clojure, then you've kind of you've ticked that box, haven't you? Really?
Exactly. I mean, for Clojure script, it's already the case. But
this was a prerequisite, wasn't it? This Clojure tools reader.
I think so, or maybe it made it even easier.
No, I'm lying. Actually, you're right. It wasn't a prerequisite, because this is only 1.7 plus, isn't it?
Exactly. Yeah.
And of course, Clojure script was out before that. But what I mean is, it's a prerequisite to bootstrapped Clojure script.
Exactly. Yeah, and also it might be one of the nicest things that you can use to move to Clojure in Clojure. So to make Clojure self-hosted.
Well, I think what you should do is just make a pull request.
Of course.
All right.
Oh yeah, you said just as well, right? Just make a pull request.
You've got most of it written, haven't you?
I think I need like a couple of years of hammock time before I can get there. I'm probably not at that level though yet.
All right, should we just round this discussion off then a bit now? I think because we've been going for quite a while on this. Oh, wow. So I just sort of noticed the time there. So I think one of the interesting things about this is that in Common Lisp and Scheme and Racket and all these other things is there are these reader macros. So users themselves can extend the reader, and this I think was the cause of much gnashing of teeth when Rich Hickey at the beginning said, "Well, you're not going to have them."
That's true. Yeah, I mean, this is one of the biggest contention points in Clojure community, I think, because most of the people who come from Lisp are used to writing their own user-defined reader macros, and there are some arguments on both sides, but I think I obviously the show is biased, so I think the choice made by Rich Hickey makes more sense because if you see Racket, for example, I mean, you can create your own language in the middle of the whole Racket language. So in the same file, you can start with language Racket and then switch to language Poland or language whatever, and then essentially you're introducing multiple languages within the same language because of the reader macros. But that would mean you are did we say complex on this podcast already?
I think we've said it. Yeah, we can do it. Go for it.
But I think we'll keep doing that in every episode then.
Yeah. It's a word that's in... I mean, I think we should, just try and throw these words in there. Yeah.
Exactly. But, I mean, that adds additional complexity. It complex the language because every library can essentially introduce its own language, which is really not what you want. And it's not common. It prevents you to have a common language in terms of Clojure. So I think that is one of the major arguments against having reader macros. But
yeah, I think you're right. I mean, it's one of these things where, to me, it's definitely, I mean, to some extent, reader macros make the language more powerful. I don't think there's any doubt about that.
Certainly.
But I think the problem is, as you say quite rightly, that power will give you the power to essentially make another language. And that makes the whole... I mean, that was one of the reasons, there were many reasons, obviously, why the Lisp didn't really catch on. But one of these reasons, I think reader macros was definitely this whole notion where you had all these guys basically writing their own languages. And, there was, that's almost like the hello world, to these guys was, okay, well, I'll just rewrite Lisp in my own image. Yeah. And then they just can't share the code.
Yeah, that's true.
If you're and why is that, by the way? Just to sort of finish that point a little bit, is that if I'm going to write a library that I want to share around, then I have to basically rely on the underpinnings of the language. This language substrate that behaves in a certain way, and I can then write these libraries. If all languages are completely different, well, I'm sitting on sand, aren't I? And that's really the advantage, I think, of this particular choice, is to limit the amount of languages out there. You can always write a DSL. There's no problem doing that. I mean, Clojure is perfect for those kind of things. Yeah. But if if you're writing the language differently, then the amount of libraries that you can write for Clojure just goes. If you write a new language essentially using reader macros, the amount of libraries that you're going to get given to that mini language are just going to drop by a factor of 1,000. So that's a very long way of explaining it. Maybe, but my point is that if you keep the language sane and common, then you'll get a lot more ecosystem on top of it.
Exactly. I think it's something similar to the code that is attributed to Rich Hickey, or maybe he said that already. Is that it's better to have limited number of data structures having multiple functions operating on it than the other way around. So
I think that was Alan Perlis, wasn't it? But long time before Rich Hickey, I think.
Yeah. Okay. So maybe I'm misquoting, but hey, we like Rich Hickey, so it's like on the internet you can just say, okay, Einstein said this.
Oh God, yeah,
or something like that.
Yeah.
Thank you for correcting me, though. But yeah, that's
what I'm here for.
to prevent me from making mistakes. Thank you, Ray.
I'm looking forward to that pull request, though, mate. I really am. I'm really looking forward to it. Yeah. And I'm sure Rich is as well. Yeah.
Well, I think we covered pretty decent amount of stuff in this episode.
Yeah.
Perhaps we should explain what we are going to talk about next time.
Yeah, I think we'll bring it up a level next time. Yeah. And discuss what we were thinking was, well, we talked about reader this time, and that's the beginning of reader val print loop. Yeah. So it would be quite nice to have a little survey or a little kind of discussion around REPLs. So around the kind of tech in REPLs, how do they work? What various REPLs we have around the community, some standalone ones, some in IDEs, and what kind of workflow the REPL brings for you as well. Okay. Some stuff around what happens when you change state, and also some other stuff with reloadable code. Yeah. So that I think we do all that kind of stuff next time around on the REPL.
So this is essentially cider versus cursive fight. So people should tune in. This is going to be a nice fight.
Okay. Right.
We'll see.
I look forward to it. Bring your best game. All right. Well, honestly, that's good. I think we went a little bit long, actually, a little bit longer than last time. But let's try and keep it under an hour. So I think we should stop here. We may. I don't know if we'll be able to cut anything out of this because it was all totally awesome. But we'll see. Okay.
Yeah.
Maybe that comment actually.
We'll see.
Okay. So do you want to wrap it up?
Yeah, I think that's pretty much it. I think.
Okay, excellent.
Yeah.
Right, well, we're going to post the show notes and all of the kind of where we actually post links to the SoundCloud MP3 on defn.audio, defn.audio. We also host the MP3 on SoundCloud. And if you go there, actually, a lot of people like SoundCloud over iTunes, it turns out.
Yeah, that's true.
And I like it a lot, actually, myself. And
I mean, you don't need to have any extra client or anything. Just go to the site and start listening. So that's much more easy. I think it's better accessible, I think.
Yeah, definitely. Yeah. But we are on iTunes as well, so if people want to get it that way. So yeah, all good. Right, well, cheers, VJ.
Yeah, thank you, Ray, and thank you to you guys and girls who are listening to this podcast, and hope to bring more Clojure joy in your way in the coming episodes.
Yeah, thanks for all the support, and hopefully we can do it all again next time.
Yep. Bye-bye.
Okay, bye.